So let's try to go from molecular formula from an empirical formula. So we just mentioned that the molecular formula itself is what's actually what is the actual compound. The empirical formula is not my actual compound. It's just the smallest ratio, the simplest ratio. So if someone gives you the empirical formula, you can determine the molecular formula from the molecular weight. And so let's look at an example. Determine the molecular weight, the molecular formula for a compound whose empirical formula is C3H4 and it has a molecular weight of 120. Okay, so this is how you do this. You determine the molecular weight of your empirical formula. So this is my empirical formula. This is not my actual compound. My compound is these 3 and 4, and I gotta multiply it by some factor, 2, 3, 4, 5, whatever. So let me get the molecular weight of this thing. I have 3 times 12 plus 4 times 1, that's 40 grams per mole. Okay. Then I will take my molecular weight of my compound that I'm given in the question, 120, and I will divide that by the molecular weight of the empirical formula, and I get 3. So it's a factor of 3. And then lastly, I multiply the subscripts of my empirical formula here by 3, by this factor, step 2. And I get that C9H12. That is my actual formula that is being discussed. It has a molecular weight of 120. Okay, its empirical formula is C3H4. So if someone were to say, I burned this thing, I don't know what, I burned something unknown, and from that I got whatever percentage I got, just like in the last question. You can only get from the percentages, from the mass percent, you can get to the mole percent, and from the mole percent you can get C3H4, like we did before with the chromium and the oxygen and the sodium. And so you get to the simplest ratio between them, but you're not actually getting to your actual compound. To do that, well, you have to use the molecular weight of your compound. So if someone gave you both pieces of information, you can get a compound just from burning it and weighing it. Okay, so that's the idea here. All right, let's talk about stoichiometry here. It's a fancy new word here, stoichiometry. And it is a way by which we can calculate reactants from products, or products from reactants, of reactants from one another. You can use a chemical equation to get the masses and moles and everything you want from one compound and into another. Okay, that's what stoichiometry means. So if I'm looking at this chemical equation down at the bottom here, I have iron oxide here, hematite, and it reacts with carbon monoxide in a blast furnace, and it forms elemental iron and carbon dioxide. Right? I can figure out from this equation after I balance it. Important balance. You have to balance it. After you balance it, if I know how many grams of this I have, I can get the number of grams of everything else. Okay, that's sort of like the magic behind the chemical equation and stoichiometry. And let's see how that works out. So we'll do 2 examples. I'll do one with the PowerPoint, and the other one I'll do by hand with you. So I have here 1,000 grams of hematite, which is a magnetic substance, and I want to know how many grams of iron I can produce from that. Okay. So just knowing that I have 1,000 grams of this, how many grams of this do I get? That's the question I have. All right. So it's going to follow a recipe again. They all follow recipes. If you follow them, you'll always get this right. What I'm going to do is take the mass, 1,000 grams, and I'm going to convert that to moles. All right. So let's do that. I convert what I know into moles. I have 1,000 grams of Fe2O3, okay? The periodic table will give me the dimensional analysis factor I need to convert from grams to moles for any compound I want. For Fe2O3, I'm going to go and I'm going to find the molecular weight for Fe, the molecular weight of oxygen. I'm going to add that up as I need to, and it's 160. So 160 grams of hematite is 1 mole of hematite. Okay, so I'm going to use that to find how many moles of hematite I have. So I have 6.25 moles of Fe2O3. Great. So first thing you always do is convert grams into moles. Whatever you have, convert to moles. Great. Now I don't want this. I have this. I want this. So I'm going to use the chemical equation to convert this into this. And I can only do that using the ratios that I have here, these coefficients. Okay, so for every 1 molecule of Fe2O3, I produce 2 molecules of Fe. It's very similar to that example of water, the red and blue that I had shown you before. I have, for every 1 of those molecule, I'll get 2 atoms of Fe. Okay, guaranteed it's always going to be that way. Now, like I said, you cannot measure 1 molecule of Fe2O3 because it's hard, it's very small. But I can measure a mole of this, and I can measure 2 moles of this. So every mole of Fe2O3, I get 2 moles of Fe. What does it practically mean? Let's get to the point. I can use this chemical equation to convert from these moles to these moles. So if I have 6.25 moles of Fe2O3, use the chemical, the coefficients here to convert. So 2 Fe is 1 Fe2O3. I'm going to put Fe2O3 at the bottom because I could cancel it out. I want to get rid of Fe2O3. This is how I convert from mole to mole. So 2 to 1 ratio, and I get that I actually have 12.5 moles of Fe. Okay? That's the crucial part, that you want to use the ratio here. Now, lastly, I need grams. I was asked for the mass of Fe, and I have moles of Fe. The moles of Fe is not what I want. There's no molometer. I have a scale. I can weigh out stuff. So I'll take 12.5 moles of Fe. I'm going to go to the periodic table. I'm going to see that my dimensional analysis tool here is 55.8 grams of Fe per 1 mole of Fe, and I'll get that I have 698 grams of iron. So for every 1,000 grams of Fe2O3, I'll get 698 grams of iron. Looking at this equation, you don't see this ratio of 1,000 to 698, and you don't. You're seeing mole ratios, not mass ratios. So that's how you do that. Now let's look at an example here. I'll do another one by hand. I have how many grams of HCl react with 5 grams of manganese oxide? That's the question. So I'm not even worrying about the products. I'm just playing with the reactants. So you can do that too. So let's look here. Here it is. How many grams of HCl react with 5 grams of manganese oxide? All right. And what we'll do the same exact thing as before. I need to convert, and I'm going to do this in one step to show you how you can do this entire thing in one step. I'm going to convert my grams into moles, use my mole ratio from the equation, and then use grams to moles again to get grams. So let's do that. I have 5 grams of manganese oxide. That's what I was given, right? I need to convert this into moles. Okay, fine. I could do that. I need to use a periodic table. How many grams per mole? Well, I'm going to go look up what Mn is on the periodic table and what O is on the periodic table. There's 2 of this and 1 of this. And guess what? If you add them up together, you get 87 grams per mole. So I have 87 grams of MnO2 is 1 mole of MnO2. Great. Right. Now, I can do this entire thing in one step, which is what I'm doing. If you follow what I had just done before, you do this in 3 steps, but you can do it in 1. Why bother? So now I got rid of grams of MnO2. Now I'm in moles of MnO2. All right, I don't want MnO2, I want HCl. If I'm looking at my equation here, for every 1 MnO2, I have 4 HCl's, right? So I'm going to use that ratio. I'm trying to cancel out MnO2, so I'll put MnO2 at the bottom. And I'm trying to go into HCl. And if I'm looking at my chemical equation here, I have 1 MnO2 and 4 HCl. Okay, and now I got rid of my MnO2, and now I have moles of HCl. Great. I don't want moles of HCl, I want grams of HCl. Well, that, again, I can go to the periodic table and figure out how to go from moles to grams. If you go to the periodic table, H is 1, Cl is 35.5. If you add them up, it's 36.5 grams per mole. Okay, at this point I want grams at the top. I want moles at the bottom to cancel out my moles. So for every 1 mole, I have 36.5 grams of HCl. And check this, HCl, mole of HCl cancels. And I get grams of HCl, which is what I want. And if you substitute, if you go 5 times 4 times 36.5 divided by 87 divided by 1 divided by 1, you get your answer. And you get that this is 8.39 grams of HCl. And that is the answer. So you can do this in 3 separate steps if you want to. You do 1 step if you want to. I always recommend, if you feel not confident in yourself, do it slowly. And then once you gain confidence, you can do it fast. It doesn't matter. No one's watching you do this, so you don't have to prove anything to anyone. You could just do this as slowly and as painstakingly as you want. If you're meticulous and painstaking, you will always get it right. If you go fast, you might get it wrong, and you'll miss a negative somewhere, and then you will lose points. I will use an anecdote I had from my chemistry professor when I was in college, and it's something that stuck with me. I cannot forget this. I had a question. It was so again, I didn't study chemistry. I studied chemical engineering, and I just took the main story is I had gotten a 5 on the AP chemistry test in high school. So I had the option of skipping Gen Chem, but my math teacher in high school told me don't skip it. We're here in high school. We taught you how high school teachers see it. You should see how engineers or how chemists teach these classes. So I took his advice and I did that. I retook all my AP classes in college, which was a pretty good idea. Anyway, my chemistry professor, he a very, very serious guy. He gave us a question on the exam. I don't remember the exact question, but it had something with nitrogen. And as you remember, nitrogen is N2. And it was a complicated question, not a complicated question, but a multi-step question. And I had at some point to convert from moles, grams to moles, to do something in the question. That wasn't the point of the question at all. It was just it was one part of it. I had to do multiple conversions of moles to grams of different substances, whatever it was. And I had to convert this. And as you know, if I had, say, 3 moles of N2, if I want to go to grams, if I go to the periodic table, N is 14. I have 2 of them, so I have 28 grams of N2 per mole of N2. And so whatever this is, whatever. So this is how you would do that. My moles cancel and I get grams. All right. What I had done by accident, because I was rushing or I was nervous or something, it's not that I didn't know it. I just wrote 14. This is wrong. This is wrong. It's not 14. It's 28 because it's N2, and I knew that. And I think I even wrote that later on. I used the 28 later on. Whatever. At some point, I got the 14. Because I was fast, I was trying to rush, and I thought, whatever. And this question was worth like 40 points or something. He took off the entire thing. He gave me 0 points. And it wasn't my nature to go to the professor afterwards and argue for points. It wasn't, but I was crushed because I understood the material. I'd gotten a 5 on the AP, and I was doing chemical engineering, and I thought chemistry is chemical engineering, which it isn't. But I thought at the point that was the same thing. And if I can't do Gen Chem, I can't do chemical engineering. And where am I going? My life is awful. So I went to him and I was very shaken and upset, and I told him, like, look at my question. I totally knew what was going on, and like, please help me out. I did know this. It was a mistake, and look, I did everything. And he looked at me in the most cold stare, and he told me, what would you tell the families? And I'm looking back to him and I'm like, what do you mean, what would I tell the families? What would you tell the families when the bridge collapses? I said, what do you mean? He's like, well, you're an engineer. You're going to have to design a bridge. And then if you made a stupid mistake like this, the whole bridge would collapse. What would you tell the families? And he gave me 0 points back. Nothing. And I went home and I had an identity crisis. Like, I'm going to switch out of chemical engineering and blah, 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 blah. Whatever. And ended up that I didn't, and I was glad for it. But point of the matter is, don't rush things. And you never know what your professor is going to do. I'm not like that. I don't believe in that. So I'll be much nicer to you, I promise. But I kind of want to share that with you because I think it's a good advice in general. Because if you rush actual decisions, you may make stupid mistakes that will cause a bridge to collapse, I suppose. Anyway, we'll talk about limiting reactants in the next video.